We have been avoiding talking about dot product for so long, so let's talk about dot product now. So as we recall that if a force F caused displacement d while making an angle theta, then the work done is given as F times d times cos of theta. Now by F we meant the magnitude of the force, and by d we meant the magnitude of the displacement. And because we know that F and d are vectors, actually we can label them like that, they have direction as well as magnitude. As you can see, actually this is in polar coordinates. When we talk about angles and magnitude, then we are actually are talking in polar coordinates, where we recall that in polar coordinates this is okay, let's assume it's XY axis. A little difficult to draw for me, but let's try. Okay, so in polar coordinates we know that we specify r and theta. So how would we write the same thing in Cartesian system, where we specify rx comma ry, where rx is nothing but this thing and ry is that, and we also know that rx is r cos theta and ry is r sin theta, where theta is the angle the vector makes in the counterclockwise direction from the x-axis. Okay, well, this thing can be written in Cartesian system as f dot d. Now it's a vector, not the magnitude. What does that mean? It means if f is fx comma fy comma fz and d is dx comma dy comma dz, then f dot d, which is f dot producted with d, is fx dx plus fy dy plus fz dz. Well, this is in 3 dimensions. You can, if you're talking about just 2 dimensions, which you will be talking most of the time, then in just 2 dimensions you will write f dot d. Depends on the problem, whether it's a 2-dimensional problem or it's a 3-dimensional problem. Right? Okay, this is just multiplication. We are multiplying the term by term. So we multiply fx by dx, fy by dy, and fz by dz. And this is same as f d cos theta. Some people prefer to write it like this, whereby these 2 lines we mean the magnitude of the vector, but I have seen people writing like that also. Okay, some more thing we can learn is that a, let's say a is a vector, dot a is going to be a square, or if you want to write a square, where a is the magnitude of the vector a. So if you dot a vector with itself, it gives you the magnitude squared. As you can clearly see, the theta is 0 when dotted with itself, so cos 0 is 1 and a times a is a square. Also, if you have something like a dot b plus c, then this is a dot b plus a dot c. So it's a linear operation, and we will be using it in, I mean, this is a sort of used in many places, the dot product. It actually has much more wide understanding and importance when we start talking about things like relativity and all that, and in many other places. And also we'll be talking about vector cross product, but that will do when we'll talk about angular momentum and other stuff. Okay.